Good day, and welcome to the demonstration of Sport Plus, the lighting planning for sport area module of Lista 4D. I'd like to start this demonstration showing you how to manage the aimings of luminary with Lista 4D. So let's start creating a very simple area, outdoor area. And let's add two luminaires coming from our database. And let's consider two asymmetric luminaires. The first one is this one. And the second one is taken from the catalog of the most used luminaires you can find over here at your right. As you can see, these luminaires, they appears to be pretty the same. But what's different is how we have to aim the two luminaires. Why? Okay, let's show the beam of these two luminaires. As you can see, one luminaire is toward the x-axis, the red axis is the x1. So one is toward the x-axis, and the other one is toward the y-axis. In any case, as you can see from the two luminaires, let's put them in this position and in this position. So these are two asymmetric luminaires. But it's difficult aiming. You have to approach the aiming of these two luminaires in a different way, because otherwise you won't aim one of them in the proper way. So as you can see over here, the luminaire has a little square, a red square over here, like the one over here. And this one is showing where the C half plane is directed. Let's say that in this case, as you can see from the properties, the program automatically recognizes that the orientation, the aiming of this luminaire should be done tilting along the x-axis. So this one is the x-axis. And if we want to aim, you can see that it will be done in the proper way, but it will be done along the x-axis. In this other case, we cannot aim along the x-axis, and the program recognizes that it should be tilted in y, along the green axis. So it should be done in this way. This is essential. This is the first step you have to consider whenever you approach the aiming of a luminaire. So if you want to manage the high mast and put the luminaires over there, you have to first consider how the measuring system was connected, was linked to the luminaire. And in function of that, if the program is not able to recognize the tilting, then you have to do it by yourself. So for example, if we consider this one and we put it down at 0, 0, 0. So it's perfectly horizontal, and we copy it. I can show you what is the difference. So these are two perfectly the same luminaires, but one is tilted along the x-axis, and the other one we change, and we want to tilt it along the y-axis. So the difference is that in this case, you can see that it is done properly. It is done in the correct way. Otherwise, in this way, in this case, it is not done in the proper way because it is tilted along the y-axis. So my suggestion is to consider the photometry you have to install, you have to consider for your lighting planning before you start the process. Let's start now with the demonstration of the Sport Plus module. So let's clean it up. The Sport module may be accessed through this icon, the wizard, and this is the wizard for sport areas. Whenever you select this one, then this window will appear. And this is the first step, Sport Center data. Why? Because through this window, you can consider the large area, the big area, where you have a sport center. So, for example, you may consider, this is not yet possible with the current version of the program, it will be in future, but our idea is to define a large area where you can have a football area, tennis courts, paddle courts, whatever you want to add to your area. So in this case, you have to define the dimension of this area. You have to define the origin of the axis. You can select the center. This is usually, from my point of view, very, very useful if you define the center for many reasons. But in any case, it depends on you. It depends how you prefer to approach the definition of the origin. Because it can be done on the bottom left corner at custom. It means that you can define the coordinates of your own. In here, you can define if it is an internal area, or, and in this case, automatically the program will create the internal area. So it will create the cover, etc. In here, you define the working plane height, so for example 1.5, and the color of this area. Let's say that it is a gray one. Over here, automatically the program is proposing the reflectance because it is calculated in function of the color that you selected so far. So in here, it is also possible to change in function of your needs. Then through next, you come to the second window where you have to define the sport area of interest. So the first one is the origin. Again, you have to define the center. You have to define the origin. For example, in this case, you have in the center of the PA. PA is the definition of principal area. You can also select in the lower left corner as before, or in the lower left corner of TA. TA is the total area. It is the area around the main area, the principal area. We come back to this point in a few seconds. Then we may define a origin position custom based, so you can define the position of your own. And over here, you define whether to orientate, whether to put the area in a horizontal position or in a vertical position. This depends on how the designer, the planner, wants to approach the design. Over here, we can define the sport choice. So, for example, if we open the window, we have a selection of sport areas over here. let's select football, and automatically, whenever we select football, the reference standard will appear. The reference standard window will appear. If we open it, we can select from here the standard we want to use for our calculation, for our planning and for our calculation. Let's stay with the European standard 1293. This standard is proposing classes. So, for example, you can select the class, the lighting class. So, for example, C1 is high level, C2 is mid-level, and C3 is low level. It means that in function of the different classes, you have different values. So, for example, for a high level football area, soccer area, it means that it is for international matches. While the C3 low level is for training, for example. In this version, this is not yet used. So you can also leave it as it is, as it comes out per default whenever you select the standard. It will be used in a future version. On the right, you can see that we have the dimensions and grids of the sport areas. So the PA and the TA, the principal area, playing area, dimensions, and the PA grid of points, the calculation points. Then the same for the TA, the total area, and TA grid. As you can see over here, it is possible to change the dimension of this area. So, for example, you can write 100 and by 68. Why? Because for football, there is not a standard, there are not standard dimensions, and so you can define a dimension of your own. More and more, we are coming to a well-defined dimensions, but we are not yet at the point. Otherwise, if we select, for example, the basket is fixed. You cannot change the dimension of the principal area, and you cannot change the dimension of the total area. The basketball area is as it is. It should be always in that way. It is not possible to have different areas. And this is happening for many sports. So let's go back to football. Let's stay with this dimension. The only dimension that cannot be changed is the TA grid along the x-axis. Then over here, we define the sport description. We may write soccer. The working plane height, again, and the color of the areas. So in this case, being football, we select the green, and this is the color that we select. Over here, it is possible to define the reflectance. So as before, once we select the color, the program automatically defines the reflectance. But as we know, whenever we deal with football, the reflectance cannot be higher than 25%. Okay, now that we have defined all the parameters, we can select next and come to the definition of the structure. It means, why do we call it structure? Because it is, let's say, a wide concept. Because through structure, we may have a panel where you can install the luminaires for your high mast, or it can be a group of luminaires that you can head, for example, at the top of a tribune. At the stadium, you know, more and more the stadiums do not have the high mast, but they have the luminaire placed at the top of the tribune. So the development of the program was done in a way so that you can be, during your lighting process, your lighting design, your lighting planning process, you can be free to place the luminaires wherever you want. For example, on the Tribune, if it is a linear one, you can define a line of luminaires, and you can move then in function of the different positions, in function also of the 3D of the Tribune you charged. So, for example, if you have special positions, you can move the luminaires, but they will be always part of the group of luminaires, of the structure. So it is also possible with our program to have a group of luminaires that you can place on a curved cover of a Tribune. And for example, this is possible. For example, we have a stadium over here in Italy, the stadium of Udine, close to Slovenia, where the Tribune is curved. And so you can place the luminaire exactly at the proper position in, let's say, in an irregular way. And this is very different from our old program, where you could have a group of luminaire exclusively in a high mast, in a panel of a high mast. In this case, you could only place the luminaires in rows and columns, and it was fixed. As we are going to show you now, with this program, you are free to place the luminaire at the high mast in the way you want to, depending also on the 3D high mast, because this is another big advantage in using Lightstar 4D, that you can import the 3D of the high mast, and so you can exactly place the luminaires. And so whenever you get the image, you select the high mast panel and you get an image, you can also transfer the image to the installers, and they will have exactly the different position of the luminaires in 3D, so that they can immediately recognize where to place the luminaires. So it is really very, very helpful. So let's define the position of the high mast. In this case, we place at minus 55, minus 45 at an height of, let's say, 25 meters. And we do not create a panel with many luminaires. My approach is to show you in a very simple way with the few luminaires how the program works. But it is clear that you can come up to a panel with, let's say, 40, 50, 60 different luminaires, even of different types. So let's stay now with the 2x2. And let's consider an interdistance in between the luminaires, two consecutive luminaires of 1 meter by 1 meter. Now it is the time to select the photometry, to select the product we want to install. At the first step, we can select only one luminaire type. And then graphically, you can select the luminaires you want to change, and you replace the previous one with the new ones. So, first step is to select the luminaire. We do it through the catalog. We open the catalog, but it can also be done opening a folder where you have LTIS or OXL files, or select the products from the catalog of the most used luminaires over here, or use the Liswin. Let's consider, for example, this one, very narrow, a little like this one. So now we have the luminaire, and that's it. We do not need to change any other parameter, and we confirm. So now the panel was added, and we can start to aim the different luminaires. But first of all, we have to aim the panel, because in this case the panel is horizontal, and so we have to tilt the panel in function of our needs. So we select the high mast, we press this icon over here, scale, and automatically you can see that even the rotation will be done along the central axis, the vertical axis of the selected object. So let's turn it. And now we want to tilt, and in order to tilt, we can do it in two different ways. The first one is graphically. So we select the aim icon. First of all, I want to remove the grid over here in order to have it much clearer. We move it, and again, we select the eye mast, and we aim the eye mast towards the center. So, towards the center. But it is also possible through the coordinates. So, for example, if you want to have it exactly at 70 degrees, and a rotation of 40 degrees. Okay, towards the center of the area. So, two different ways. In the first one, if we use the graphical approach, then it won't be possible to define exactly the rotations. Let's say a rounded value, so 75 degrees, 70 degrees, etc. Why? This is possible through the coordinates. Okay, now it is the time to aim the different luminaires. In order to do that, we found that it is very convenient to select the eye mast, modify, so automatically the program will present this window that, for example, you can put to a second monitor and have it on one side, and then if you want, you can do the aiming, for example, graphically. So in this case, I usually reduce the area. I can have the view exactly from the back of the panel and see the area. From here, I have the 2D view, top view, and in this case, I have the 3D perspective view. Now, it's time to select the luminaires. We can select the luminaires in three different ways. So the first one is through the tree that we have on the left. The second one is clicking on the luminaire on here at this view, the panel view, or it is also possible to select a luminaire from the aiming. We just select the luminaire, we click, and the luminaire will be automatically selected. From here, once we have selected the luminaire, we can aim. So, for example, we may say that this one is aimed in this direction. Then we select the second one, and it is aimed in this other direction. Then we come to the top ones. And so the first one will be in this direction, and the last one in this direction. But as you can see, I made an error, so I didn't select the luminaires in the proper way. So the two luminaires, the top luminaires, were aimed at the same point. So no problem. We leave the number 2 in this position. Then we select number 4, and we bring it back to the original position. Let's say that we have finished to aim the luminaires. At this stage, we may say that we want to split the group of luminaires in function of the lighting level. So, for example, we may define a level for the training and a level for the matches. How can we do that? We select the luminaire layer, As you can see, all the luminaires now are belonging to this layer. Okay. And let's say that this is, we rename the layer, and this is the layer for match. Okay. And now we want to select only the number 2 and number 4. It is also possible to select 2 luminaires pressing Control at your keyboard. And then we come here, right click of your mouse button, assign, and that's it. And now the other 2 will be added to another layer that we can create. Right click of your mouse button, new layer, and this is raining. Okay. And now we want to define a different color, and we say that the color now is orange. The 2 luminaires were selected, right click, assign selected objects, and as you can see, the beam line was changed to orange, and also the little point you have here, it is, so if we select IMS, you see that it is now in function of the group, in function of the layer. So now we have finished to, let's say that we have finished to define the aimings, and we want to run a fast calculation. So we select the calculation, we bring this one down to 0. So it means that for the rough calculation that we want to perform now, we don't need to have all the rendering parameter calculations. So we bring it down, we start, and in few seconds, we have the summary of all the results that we have selected. In this case, we didn't select too many results. So let's go back. We forgot to select also the vertical illuminances. So from here, we can select the vertical illuminances, cylindrical illuminances, and let's say that we want to add also the GR, the glare calculation. Let's spend a few words about the GR calculation. As you can see here, it is possible to select the 2 different options. The first one is considering only the calculation in function of the luminaires. So from our point of view, this is from one point of view, a more correct approach. Why? Because it is clear that if we do not have any luminary in this direction, it is not possible to have high values. But you are glared only when you're facing directly one luminary or one panel. But it is also possible to perform the calculations in function of the different number of directions. In this case, 12 directions. So it means 1 every 30 degrees. So the first one is along the x-axis. And then step by step, a step of 30 degrees, you have a total of 12 directions per any observer. In this case, with 45, we have 8 directions, 6 with 60 degrees, and 4 with 90 degrees. In this case, it's clear we have 1 in the positive x direction, positive y direction, negative x direction, and negative y direction. Let's stay with this one. Over here, the program is automatically adding the different observers in function of the standard, 19 observers, but it is also possible to delete one or more of them, to add other observers, or to modify the position and the line of view of the different observers. So let's stay with this configuration and let's start again the calculations. After a few seconds, you will have the calculation. At the top, you have the glare, the calculation of the glare. In this case, it is 50, so we are exactly at the limit. In this case, we are above the limit. It's clear because we are aiming the luminaires far away, so it is possible that with a very intense beam, because we selected very intense beam with our luminaires, then it is possible that we come up with a very high GR value. Down here, it is possible to visualize the different horizontal illuminances, the vertical illuminances, the cylindrical illuminances, and then the energy efficiency assessment in function of the area, but this is not of interest for our calculation right now. So we may select different results, but first of all, I'd like to show you another feature, which is a very interesting feature with the program. So over here, we have the result configuration. Let's close all the result configuration that was added in a previous calculation. And over here, we also reset, so we bring the previous configuration to 0. Let's go back to the result summary table. We select, for example, the PA area, we select the TA area, we select at the working plane of 1.5, and we select values. So automatically the values will appear. Now we want to add other results. So for example, the vertical illuminances, we select the 4 and we select values. It's clear that in this case, being minus y direction, all the values are 0. It won't be the same once we had the symmetric HIMAST. In few seconds, we can see it. So once we have selected the tables of interest, the results of interest, then we can add the results, as you can see, and this will be automatically saved as the configuration of the results of interest for the designer, for the planner. So whenever we go back to the calculation, for example, we found that the aiming is not going in the proper direction, so we want to change, as you can see. We change and we run again the calculation. Once we have finished, it is not the case to select again the results, but they will be over here already available for our analysis. So we simply select the result of interest and the program will automatically show the result. We can check it, and if it is okay, we can also, so let's say that it is also possible to have to add pseudo color, the false color diagram. We can also add the isolines, and with modify, we can say that in order to have a better view, we can select only few curves. So for example, in place of having a step of 23, we may say a step of 50. So you can see that the values will be, the number of curves will be reduced. So let's stay with 10 and let's confirm. So this is much clearer than before. So they are here and we can add the results. So in place now of 7 results in the configuration, we have 9. Now we come to another point, which is the symmetrization of the high mast. So in this case, we go back, we select the high mast, the mast, and we select symmetrize. This window will appear, and through this window, we want to have a double symmetrization. Once we confirm, the program will show me the new situation over here. And now we go back to the calculation. And once the calculation are over, we can have here the list of results. As you can see, this is the symmetrization, the result of coming after the symmetrization. It's clear that this is not the proper lighting, so we have to work on it in order to improve the uniformities. About the uniformities, through the program, it is also possible. So, for example, whenever we select the window where we want to show the results over here, so in this case, it is also possible to select two different functions, the gradient and the Mauer. The Mauer and the gradient are two different ways of considering the uniformities. So one system is done over here. So minimum over average values, minimum over maximum, and average over maximum. This is what the set of uniformities that we usually use. But for example, if you want to deal with high with FIFA calculation for football stadiums, then we have to consider the Mauer. And the Mauer is considering the variation in 4 different directions. So this one is the calculated point. And in this so you have 4 directions, the x, the y, the minus x, and the minus y. And this calculation is done considering the closed points. And the variation, and the Mauer is giving the variation in between those points. So whenever we have a value in red color, it means that we are above the limit. Whenever we have a green color, like in this case, as you can see, we have a low value, which is not far away to be correct, but it is not correct. And this one is the minimum. So we have different ranges, and through the different colors, the designer may recognize where it is necessary to apply some changes in order to improve the values. This can be done in this way. This can be done analyzing, for example, the false color diagrams or the Eisenlux diagram. Okay. At this stage, let's say that we go back to the 3D view and we want to have the high mast, because from our point of view, it is not the case to manage the 3D of your high mast once you are defining the aimings. So now we can add the IMAST. Through here, I have a folder with OXF files. The OXF files is pretty the same, like the structure is almost the same like the OXL file, but in place of managing then the photometry, we manage a 3D object, like the high mast. So OXF means oxy furniture, Oxy object. And it is managed exactly in the same way like with the RxL. So you can simply drag and drop into your project. Once you imported the HiMest, then you want to place it at the proper position. So you move it, for example, over here. It is better to move it above over here, so we come exactly to the point. And as you can see, it is now necessary to place the panel exactly at the proper position. So we zoom, for example, over here. Scene, this one, the HiMest. We zoom over here, or we select this one and we zoom again, and we move it step by step towards the panel. It is clear that now we have to turn, and we can do it through this icon, select the blue line, and we turn exactly the HiMest in function of the panel. Now it is the case to move to the right view and place the HiMest at the proper position. Probably I made a mistake in moving the HiMest, so I placed the 0 down. Now it is properly placed. We go back to the HiMest, and step by step we pull up the panel, and we move it to the proper position. That's it. So now it is the case to, for example, to create the other HiMest. So we remove the symmetrization of the other panels. We select again the HiMest. We select Symmetrize. We confirm with OK. And so the other Hemmings were added. At this stage, we want to symmetrize also the HiMest. So we select the model F5R. We select Symmetrize. And so the other HiMest were added, as you can see here. It is also possible, if we select the third HiMest, and you don't want to carry them during the aiming process, it is also possible to add the HiMest to a proper layer. So we create a new layer. We say that it is a HiMest. Okay. And the selected object will be placed with right-click, assign selected object, and if we do not want to visualize them, we simply select this one. And so, as you can see, they will disappear. So only one was disappeared because, yes, we made the symmetrization, and so this one are blocked. Yes, this is a little mistake of the program. So now that we have the HiMest, we can run again the calculation. But you have to consider that managing the HiMest, it is adding surfaces, so it will take a little bit longer than before. So the calculation time will be a little bit longer. But as you can see over here, through the rendering, you can also have the shadows of the HiMest. So you can come to a quite interesting point. So let's consider now that we want to add other luminaires in order to, so for example, we found that the lighting level that we reached with these luminaires, it is not enough. So we need to add more luminaires to my panel. How can we do that? First of all, we remove the other symmetrized objects. We come to the panel view. So in this case, we do not visualize this one. We come to scene, we select high master, and again modify. So we want to have this one. And we say that we want to lock the aimings to this position. So during this process, maybe it is necessary to move a little bit the luminaires, but it is not the case. Having done the work so far, the aiming work so far, it is not the case to move the aimings. So we freeze the aimings to the ground, and now we are free to move the luminaires. So, for example, in this case, we want to add another row of luminaires. We come to this window and we put 3, always with an interdistance of in x and y of 1 meter. So once we select this one, and we press OK, then the high master, as you can see here, the panel is now based on 6 elements. So we select the group of luminaires and we move them. We select the luminaires and we move all the luminaires in the proper position. As you can see, we have a tilted panel. And this tilted panel is giving me a plane. And once I have selected the local coordinate systems, it is possible to move the luminaires exactly along the area of interest, in this case, the panel. It is different if we select this one, because using that one, it is the luminaires are moved in function of the origin of the absolute system of axes. So this is very useful because you do not have to consider and it is done. So as you can see, it is possible to move the luminaires in a very simple way, and you work exactly on the panel of interest. So let's say now that we want to add 2 luminaires. So we select these 2 luminaires and we select this icon. So duplicate. The 2 luminaires were duplicated. They are over here, and now we move them towards the new position. I don't see them. What's wrong? So I select 2 luminaires, one and this one, and I duplicate. I cannot see them because they were added to the layer. Okay, so now that it is clear, I turn around and I say that these 2 added luminaires, so these 2 last luminaires, they are part not of the high master, they are part of the default layer, and they are part of the training layer again. So now if we want to go back and remove this one, as you can see, you can find the layer. You hide the high mass layer, and you can find all the luminaires. So again, it is the question now to aim the two luminaires that we had in the position of interest. These two luminaires are using, having blocked the aimings at the mast, if you remember at the window, we open it. Okay, we unlock the luminaires, we confirm, and then we can come to the point of aiming the two luminaires. So let's say that we aim them over here, and again, this one, the number 6, over here. So this one, not having blocked before, probably I moved the two luminaires, so we bring them back to the proper position. And so from now, we start again with the calculation, and once we're finished, if the result is the result of interest for us, we can symmetrize and run again the calculation, and that's it. So we analyze the horizontal values. We may say, okay, it is okay. We go back over here, and we select the high mast, and we symmetrize again. We run again the calculation. We close the result window, and from here we visualize the result of interest. All the results over here will be brought to the printout page, where you can, at this stage, you can select what you want to print. So all the results you have here is summarized over here. So you can select if you want to print or not one or more values. There is another interesting point about the calculation. So we found that sometimes the calculation are performed. We also found, considering the calculation from other programs, they are, for example, the vertical luminances are calculated considering also the interreflection of the green area in this case. If you want to do that, so if you want to consider for the vertical illuminances also the contribution of the ground reflection, then in place of running calculation, considering direct component only, you select this one. So you run the calculation considering the direct component, but also the reflected component. It's clear that the reflection will help to improve the vertical values. It's up to the different lighting planners. As you can see here, once we have finished the calculation, we have the calculation in function of the four towers in the first high mast. Let's consider what's happening once we calculate in function of, for example, in this case, 8 directions. As you can see, we have the four. Did I select how many directions? So 4 directions. It should be like it was not updated. So over here we have the 4 directions. So it means direction 0 along the positive x-axis, 90 degrees, 180, and 270. as you can see here, there are 0 values. It is what I was telling you before. If you're viewing in a direction where you do not have any luminaire, it is clear that the value will be 0. So this is why we usually calculate from our point of view, considering the direction given by the position of the observer and the position of the luminaires. Okay, that's it.
Thanks.